At my denominator, and I realized that it is in the format of difference of 2 squared, where I can write the 9 as 3 squared, and the sine squared x is typically sine x being squared. So you can express it as 3 minus sine x multiplied with 3 plus sine x, and then the numerator is just cos x. So many students would want to express this in the partial fraction format. So what they will do, they will write a over 3 minus sine x. This is where the problem actually starts, because the student is writing a on top, and here they will do b over 3 plus sine x. Why do they do this kind of error? Not to say an error, it's because you have been trained to do algebra. If you have, let's say, 1 minus 3x, of course you will try to create a constant on top. Let's say if you are having 2x squared minus 3 at the bottom, then you are trained to write a linear on top as ax plus b. But let's look at some concept check, okay? Not to say concept check, a trick way of solving. You are trying to express your final answer in the form of a ln, correct? Now here you are having a sine x. If you want to express this in a ln form, when you integrate, you should be able to have that light bulb moment where if my denominator is sine x, then on top I must have a cos x. Only then when you integrate, you will end up writing it as ln, right? Ln sin x plus c. So that's the first time you're actually seeing the ln existing. Okay, there is also another shortcut where you know that if you differentiate a linear, you end up getting a constant. If you differentiate a quadratic, then you end up getting a linear expression on top. So what will happen if you differentiate sin x? You will actually get a cos x. So you can think and create the cos x by looking at the ln here, or you can go back to your algebra partial fraction and see a pattern from that. So you need to add cos x in your numerator. Only then your partial fraction expression is correct and you can start solving as usual. So what I will do, I will try to cross multiply. So I'm going to go this way and the other side. Let's see what happens. I will get 3a cos x plus a sin x cos x, and on the other one I'm getting 3b cos x minus b sin x cos x, where I can compare it with my left hand side now, which is cos x. So what is the coefficient of cos x on the left? It's a 1. So let's check where do I actually get the cos x from the right hand side. I have a cos x here, and I also have a cos x here, and this is also a cos x. When I compare the coefficient, then I end up getting, so I compare coefficient of cos x, which will give me 1 equal to 3a plus 3b. I also have sin x cos x here, where the coefficients are a minus b from my right hand side. So what do I have on my left hand side? I have nothing remaining. So logically you have to take it as a 0. So you can actually think maybe you are having 0 sin x cos x. That's the only way you can balance it. Now you solve them by simultaneous equation. So let's say I get 3a and I want to add them up. I will end up getting 6a equals to 1. So a is 1 over 6, where it is exactly your b. So once you have reached at this step, then you can start writing. So I am going to do integration of 1 over 6 cos x over 3 minus sin x. Again 1 over 6 cos x over 3 plus sin x with respect to my dx. Since I have 1 over x on both sides, I think you can see that here. See, I have 1 over 6 here and I also have 1 over 6 here. So I'm going to drag the constant out. Okay, now we have what we are seeing as I write here. Okay, then what form is this? What form is this? If you differentiate your sin x, are you getting cos x? So it's a perfect fit. So you can write this as ln 3 plus sin x. How about the other one here? If you differentiate negative sin x, you should actually get negative cos x. But do you have a negative here? You don't. So what you will do, you will just balance it by putting negative ln 3 minus sine x. The 1 over 6 stays there, and we are done with our integration. To make your life easy, you can use the law of logarithms and merge them together. Over 3 minus sine x. If you have forgotten, what am I doing here? This is like negative ln, let's say a plus by ln b. So what is ln b minus ln a? It is exactly ln b over a. So that's what I have done. Then I will take my limits, which is pi over 2 and 0, and I can put them in. Let's see what happens. 1 over 6 ln sine 90, it's equal to 1. So I get a 4 over 2 here minus ln, let's put a curly bracket here. I keep the 1 over 6 outside. Sine of 0 is 0. So it's just a ln 1 over 6 ln 2 shown.